Hello students, welcome to our online video tutorial class. Today I have decided that I will be starting the topic that is pollen pistil interaction, that is belonging from the chapter sexual reproduction in flowering plant. So I am starting with the topic that is pollen pistil interaction. So in this specific point there is a large process, whatever I have written throughout the entire board. So first of all we have to know what is pollen pistil interaction. Pollen pistil interaction is none other than the interaction in between pollen and the stigma surface, due to which pollen grain is getting the entry within the style, and after that the two male gametes will be getting the chance to reach up to ovule. So pollen pistil interaction is the interaction in between the surface of pollen grain and the surface of stigma, for which the pollen tube is forming, and further through that pollen tube two male gametes will be moving towards the ovule via style. So let's see what is the mechanism, whatever the interaction is happening in between them. First you can see, we all know during the time of pollination pollen falls on stigma always. Second point, you can see pollen interacts with stigma surface by mucilaginous outgrowth and stigma by papillonaceous outgrowth. That means if you see the microscopic structure of the pollen grain, you have seen that on the surface of the pollen grain several outgrowths or several bristle-like structures, so which is actually present on the layer of exine. So those specific outgrowths are commonly known as mucilaginous outgrowth. Okay. Second thing is that on the surface of stigma, that is also, if you see under the microscope, you will be seeing that there is also some outgrowth on the surface of stigma. That is commonly known as papillonaceous outgrowth. Okay, so these two outgrowths are actually interdigitating with each other, okay, for interacting. So that is happening in the second step after landing the pollen grain on the stigma. Third step, you can see the interaction determines the compatibility between pollen grain and stigma surface. Always, we have to keep it in our mind that when this pollen grain is coming on the stigma surface, obviously it can make us understand whether the interaction is happening or whether the pollen grain is compatible for the stigma or not. That is understood when the interaction is happening in between mucilaginous outgrowth of pollen grain and papillonaceous outgrowth of the stigma. Next, if pollen grain accepted, there is a chance of rejection also, because if the pollen grain has come from any other plant, on that time the pollen grain will be rejected. Because this interaction, when it is happening, on that time the stigma surface can understand that okay, this pollen grain is not belonging from my species, it is belonging from any other species. So automatically stigma will not accept. But if it is accepted, on that case the process is continuing. What is the process? Stigma releases sticky fluid. If the pollen grain accepted, then only. In that liquid, which is present, the liquid is present, that is water is there, gum is also there, as well as resin is also present. So these three constituents is containing that sticky fluid. Clear? After that, that fluid will be absorbed by the pollen grain and it gets soluble. Obviously, pollen grain will start absorbing that specific sticky fluid. I have already told you that when the pollen is coming on the surface of stigma, first of all, pollen will start absorbing the sticky fluid from the stigma surface, and after that the pollen grain will be get soluble, and automatically what will happen? The intine layer, that is the inner layer of the pollen grain, it will be coming out through germ furrow by forming the pollen tube. This is the mechanism we all know. So here also same thing I have written. Fluid will be absorbed by the pollen grain and it gets soluble. Clear? Next, pollen grain germinates by few enzymes. Now the pollen grain swollen, clear, but swollen, that means that the intine layer will be coming out by forming the pollen tape. It's not true. So what is true? The true is pollen grain germinates by the help of few enzymes. Few enzyme is actually acting there for the germination of the pollen grain. So what are those enzymes? Alkaline phosphatase, esterase, amylase. These specific enzymes are responsible for rupturing the outer layer, or rather you can say they are responsible for preparing or producing the germ furrow-like aperture on the surface of exine, through which the intine layer will come out and form the pollen tube. Clear? Next step, cutinase is another enzyme which degrades the cutin on the stigma surface and within inner wall of style. Here, with this specific enzymes, cutinase enzyme is also releasing from the pollen grain, which can degrade the cutin surface which is present on the stigma, as well as the cutin surface which is present inside the inner wall of style. So that degradation is also required. Otherwise, the pollen tube can't proceed forward through the style. Next step, pollen grain can produce single or multiple pollen tube, but one is acting always. Now the pollen grain, we know that when we have studied about the structure of pollen grain, there we have seen that pollen grain on the surface of the enzyme 2 to 3 germ furrow is present. So through the 2 to 3 germ furrow, 2 to 3 pollen tube can come out, and those 2 to 3 pollen tube can enter within the style. But always we have to keep it in our mind that always single pollen tube will be functional. The remaining pollen tube will not be functional. Only one will be acting on that time. Next, ovule will also or always secrete some chemicals to attract that pollen tube towards them. So just one pollen tube is entering within the style, or one pollen tube is acting as a functional pollen tube. Automatically ovule, when gets the information or gets the signal, it will also start secreting the chemicals to attract the pollen tube towards it. Okay. Then to restrict the movement of the cytoplasm to the tip of the pollen tube, callus plug is formed in the regular interval before tube nucleus. Here one point we have to know that when you have seen the figure in the book, that pollen tube is moving downward through the style, and at the apical portion of the pollen tube or the tip portion of the pollen tube, 2 male nucleus is present. With that, one tube nucleus is also present. So these 3 specific nucleus, tube nucleus first, then 2 male gametes. When these 3 nucleus is moving down, obviously there should be a force of attraction towards down, because ovule is also attracting. But in that time what is happening, the cytoplasm which is present within the pollen tube now, that is actually moving front, that is coming to the tip of the pollen tube. Then the tube nucleus is there, then 2 male gametes are there. But to restrict that movement of the cytoplasm, because cytoplasm is a fluid part, so it will be moving fast. So to restrict the movement of the cytoplasm, what is happening, throughout the length of the pollen tube, in different interval, callus plug is forming. Suppose I am showing you, suppose this is the surface of the stigma and this is the style. Okay, if the pollen tube is coming like this, suppose the pollen tube is coming like this, here there is presence of one tube nucleus, here 2 male gametes are present. So when it is moving downward, callus plug is actually forming. Suppose here it will be get forming. So the pollen tube is not moving very smoothly. It is getting the restriction due to the presence of this callus plug. Suppose when the pollen tube has come here, again the callus plug will be forming here. So like that, in a specific distance related interval or in a specific interval, those callus plugs will be forming to restrict the movement of the cytoplasm inside that specific pollen tube, so that the pollen tube will not be moving very fast towards the ovule. So callus plug, that's why it is very much important. Callus is actually one kind of sugar, and that sugar is actually making one wall-like structure. That is actually known as this callus plug. Callus plug is actually the wall made up of sugar, callus sugar, and that is restricting the movement of cytoplasm when the pollen tube is moving downward. Clear? So this is the overall the process of pollen pistil interaction. Pollen and pistil, they are interacting with each other on the surface of stigma, and then pollen is getting some sticky fluid from the surface of stigma. It is absorbing that. After that, some enzymes will be released by the pollen grain to germinate that pollen grain, as well as it is releasing cutinase, by which the stigma surface cutin layer will be degraded, as well as the cutin which is present inside the wall of style, that will be also get degraded. So after all degradation, what is happening? Pollen grain can produce single or multiple pollen tube, but one will be always remain active. Next, ovule always will, when the ovule will also get the signal from the pollen tube that it has entered, automatically it will also start releasing chemical towards the pollen tube to attract it. Okay, so when the pollen tube will get that signal, it will automatically move towards the ovule through the style. But when it is moving on, as cytoplasm is moving at front, then tube nucleus, then 2 male gamete. But to restrict the movement of the cytoplasm in a specific distance interval, that callus plug or the callus wall has been formed, so that the pollen tube will move in a smooth manner, in a slow manner. It will not move in a faster rate or quick rate. Clear? So this is entirely the pollen pistil interaction. I think you have understood this entire portion, whatever I have taught. and please write down this specific flow chart because it will help you to represent your answer during the time of exam. And you have enjoyed this video, I think, a lot. So thank you.